Alright, today I'll be showing you basically what happens when I fuck around. So I got two transformers wired in series. One as an inductive load, one is the burner. And on the secondary I got this multimeter. And I got it in a variac so you could see the input voltage is 31 volts, 30. And I just have this one set up so you could see what, even when I turn it down all the way to 0, leakage current, you get 0.2 volts, and that's enough to put out 5 volts on the secondary. That's how much of a step up it is. So after that, we don't need that. So get that out of there. And so bump it up. And once you get about 30 volts, this turns on. And we can see how many amps it's drawing. Yeah, 0.17 amps. And if we short circuit the secondary on the inductor transformer, you can see volts go way up. You get about 670, and the amps go up a little from 0.17 to about 0.2. This is only 36 volts, so you can figure about 4 times that. Well, you drop down to about 32. 4 times that is probably what you'll get from just plugging it straight into the wall outlet. So probably, yeah, 1400, 1500 volts. And then if you have this shorted, then you got, 4 times that, you get about 2500 volts. So you get about 1000 volt difference, whether that's shorter or not. And if you have a good potentiometer, you could probably even have it vary. This one's only 300 volt rated, but with the proper resistor with a high enough wattage, because that'll be putting out a lot of heat dissipated. But other than that, that's basically how the inductor one works. You can turn it up, and you see a little spark there. 800 volts, and the multimeter says 750, but it can take 1000, I bet. You definitely want a good connection there. So, what else was going to try? Pause. And I can show you they are in phase, because you can, well, yeah, it's off now, so take to the secondary on that side and test it with the secondary on this side when it's on. And I'll stick that under there so it's making good connection too. Actually, no. Leave it like that. And you get no voltage potential difference between these two. Yeah. 0. And then you could still secure it to the, notice I'm doing the one hand rule now, especially with it live 200 volts on there, our secondary side. Stay in there, stupid. know y'all want to see me get shocked, but this ain't the time nor the place, you know. It's time for everything. This ain't that kind of fuck around. I don't want to find that out. So, still no voltage potential between the two cores, even though they're not connected in the center. But with that grounded, you get 600 volts from 30 volts. So yeah, it's still about 2500, and probably be drawing about an amp on primary side. So the current is far less too. Whereas if we disconnect that one and plug it in. Oh yeah, it's getting 10 volts now because it's just by itself. And it's just turned down to 0, not flipped off. So let's see. What we got is 0.2 volts, and we're getting 10 out instead of 5 before with an inductive second or in series. So and if I turn it up, oh yeah, I want to see, since it goes up so quick, doesn't have time to barely turn on before it hits the limit. So putting sitting at 2 volts, and we're getting 45 out with just the primary, one transformer at 4 kilovolts. It goes up real fast, and you get about 20 volts, and you're at 400 already. So 6 times that, and it's still 2400, I guess. I don't know why. 30 volts. Yeah. I don't know why I wrote 4 kV on there. Oh yeah, because I just had it in series with a 4 kV that had listed as 4 kV, and it was balanced on the secondary, so I figured it was the same, which apparently is not always the case. So 4 times that, yeah. Up there, 2,800, almost 3,000. And it might not be linear too, because it could go up more, bell curve style. So it might be only a 2,500 volt transformer. Fuck around, you find out. Jesus. Yeah, so yeah, but probably only 2,500, 2.5 kV. So I got others to fuck around with. This one is that 4,000 volt 4 kV that I compared it to and thought it was equal to. So disconnect and switch off. Yeah. And okay. They're different size fucking leads. So do a temporary kind of fucking like that, and yeah, just like that. And just clamp it to it. So we are not fully connected yet. Power back off, even though it's turned down. Secondary. 1 and 2. There. So, what's not connected? This. I want to find out. Set point 2. Nothing yet. That's probably why. Just got to make sure you got a decent grounding through that metal, because it's going to have a coating on it that's going to prevent it from connecting easy. So, still nothing. It's good to go off a screw hole, usually. There we go. Now we're getting 10 volts out of it. So we turn it up. It's still going. Now with 5 volts you get almost 120 out. So this escalates quickly. So that's definitely a 4 kV transformer, because I want to get to 30 before it hits the limit, maybe. Oh no, we get it. And drawing a 1/4 amp. 4 times that. Wait, why is that on? Still seems a little short of 4 kV, but 1/4 amps would probably be a bit more too. I don't know. Maybe that other one is 4 kV also, and it's just a little curve at the end. So, here. Let's disconnect. Stick that back on. Use this one again. Use those two. There. Okay. 3.6 volts in, 40 out, with secondary not shunted. With it shunted, we get 150. Not, we get 80. Alright. 30. So I got one on each of the secondaries. Yep, that's why. And I just realized what's probably also taken away from the voltage these are getting is the meter. If I had this hooked up on a secondary or a second outlet, totally separate from this, it would probably be the full 4 kV. In fact, I want to try that just by removing it. Oh, but now I can't tell how much it's getting because both meters are occupied. Fuck me. Okay, well, it's not gonna. It's not making a good enough connection on there. Let's see. Yeah, let's turn down. Yeah, that was the limit. So slowly turn it up. So yeah, they're about the same, 4 kV each, and I suppose that is technically hooked up now. Show me the voltage. So about 30. So now it's going to act as a voltage divider also. So when it gets 13 volts, it's not evenly splitting it either. Yeah. So I can give me. So off this one, here I'll do it one-handed just for safety. You get 13 to that one out of 30, and $15 to that one, with this one consuming about 2 then of the 30. So let's look at that with a shunt. About 600. And if we disconnect this primary safely, successfully, so that we move that. I don't want to get shocked. Don't shock me, fucker. So with that removed, it didn't really change. Still about 600. Yeah. Here, this added again. .6 volts. We're on this side of it. Not enough to turn on, but on that side. So we're at 34 on that side. If we go back to this side, it's the whole voltage, 59. So majority is going to that one, so that's why the secondary is going to be higher. And if we short it, boost that one way up. Oh, over 1,000. See, told you get to handle it.